Today we are working with the gradient of a graph. All right, we have a lot to do, so I'm going to get started. Hi, Kelly Ann. Okay, now let's talk about finding the equation of a linear or straight function. So this is the general formula we use where we substitute stuff to find the equation of a graph. Okay, so it's generally y equals mx plus c, and today m is what we're going to be working with. Okay, so m stands for the gradient in this formula, and c, we're going to touch on c as well, but mainly today the lesson is about m, which is the gradient. All right, so m and c are just placeholders for numbers. In other words, they could be anything. They could be ax plus q, they could be bx plus z. They're just placeholders, nah? Your mission is to just know what they stand for. So m, as I said, would be your gradient, and I'm going to show you today how we find that gradient and how we substitute it to eventually find the equation of the graph. Okay, now let's see. This is my formula to find the gradient. So let's see what it says. It says gradient, which we generally represent with m, as I told you. So I'm going to write here m. M is equal to the change in y values divided by the change in x values. Now let's talk about what this means. Okay, I'm going to write down two coordinates over here. I'm going to write A, which is 2 and 4, and B, that I'm going to make 1 and 2. Okay, so I have two coordinates over here. Change in can also be rewritten or interpreted as difference. So the gradient can be calculated by finding the difference of the y values and dividing it by the difference of the x values. Which x and y values am I talking about, you ask? The ones in the coordinates. So then, this 4 and this 2 would be your y values, right? And this 2 and this 1 would be your x values. Now tell me, guys, remind me, which operation is difference? If I say you're finding the difference of something, which operation would you use in mathematics? I mean, mathematics. Oh. Thank you, Kwezi. Yes. So that means we are going to subtract the y coordinates and then divide it by the difference of the x coordinates. Okay, so now I'm going to first write it in notation form to tell you what I am doing. So m gradient is equal to the difference minus, okay, of the y at A minus the y at B. I'm saying exactly the same thing. I am just writing it in a different form. Thank you, Tammy. That's also another way to write it, okay? Divided by the x at A minus the x at B. Okay, now a few things to take into consideration here. First thing is, these points have to be in the same order. So what I mean is, it doesn't matter if you start with the y of B or the y of A, but if you're going to start with the y of A, then you also have to start with the x of A. So they have to be in order. And then it will be the y of B and the x of B. You cannot swap them around. So you can't say y of A minus y of B over x of B minus x of A, because that would be incorrect. You can't swap them around, okay? You need to commit to an order. So if you're going to start with the coordinates of A, then start with A on both of them. And if you're going to end off with the coordinates of B, then end off with them on both of them. Okay, now tell me, let's substitute. What is the y coordinate for A? What is the y coordinate for A, for point A? 4. Minus, what is the y coordinate for B? Why is my pen so thin? I can barely see it. 2. Beautiful. Divided by, Kwezi, I'll take your question just now. What is the x coordinate for A? 2 again. Minus, what is the x coordinate for B? 1. So this will be equal to 4 minus 2. Yes, Kimora. Kimora is steps ahead of us. That would be 2 over 1, which is just 2. Do we understand how we work out the gradient? Let me check in, thumbs up, thumbs down, while I hear Kwezi's question. Yes, Kwezi.
Hi, ma'am.
Hello.
Ma'am, I'm confused. Where did you get these numbers from? The 4 minus 2 over 2 minus 1.
You see the 2 coordinates that I've written on the screen?
Oh, yes, ma'am.
We get them from there, okay? So Kwezi, let's remind each other, how do we write coordinates? We write coordinates by writing the x coordinates, semicolon, the y coordinates. Do you agree?
Yes, ma'am.
So we're going to go here. If I said to you, the y of A, I mean the y coordinate of A. So let's look at the point A. What is the y coordinate here?
It's 2. I mean, 4.
4. So do you see where this 4 comes from?
Yes, ma'am.
Minus the y coordinate of B. Now let's look at point B. What is the y coordinate for point B?
It's 2.
Do you see where it comes from?
Yes, ma'am.
Then we divide it by the x coordinate for A. We go back to point A. The x coordinate is 2 minus the x coordinate of B. The x coordinate of B is 1.
Yes, ma'am.
You see now?
Yes. Thank you, ma'am.
You're welcome. I saw a question. Kwezi, the x points are always first. That's how we write coordinates, remember? Look over here. We always write the coordinates x first and then y. It's never the other way around. Okay. So that's how we always write coordinates. That's how you know. Yes, Kwezi.
Ma'am, can you please explain again, ma'am? I'm very confused.
Where did I lose you, Kwezi?
Ma'am, when you wrote like the formula for YA minus YB.
Okay, listen, Kwezi. You see over here on the bottom, we said
Yes,
you find out gradient. Okay, let me use a different color. Gradient, the formula for a gradient is the change or the difference in y values. What does difference mean, Kwezi?
difference between the Y and the X, right?
Yes. No, difference between the 2 y's and the 2 x's. So remember, it says difference in the y values. Do you see that?
Yes, ma'am. Yes, ma'am.
So which operation do we associate with difference?
Is it divide or minusing?
It's definitely not divide, it is subtract. That's where the subtract.
Yeah.
You see now?
Yes, ma'am.
And then if you're going to say the difference of the y values, then you have to use the 2 y values. So you have to use the y of A minus the y of B. Do you understand?
Yes, ma'am.
And then at the bottom, we said the difference of x values. So you're going to take the x of A and you're going to subtract the x of B. So it's y and y. At the bottom, it's x and x. And then you just substitute from there.
Okay. Thank you, ma'am.
Noko, are you there?
Hi, ma'am.
Hello.
Sorry, ma'am. I forgot to put my hand down.
Oh, okay. All right, all right. So, guys, coefficient means number in front of. Ooh, we need to go revise our algebra. Coefficient means the number in front of the x. Okay. So I'm guessing we are all feeling a bit better now. So we have to say always the difference of the y's divided by the difference of the x's. Now let's practice. I think we should practice first. Let's practice. Okay. We have a point there, P and Q. Okay. I'm going to rewrite my formula. M is equal to the y of P minus the y of Q over the x of P minus the x of Q. So as you can see, the P's are both first and the Q's are both second. Okay, now let's substitute. What is the y coordinate for P? Yes, yes, Abu. What is my y coordinate for P? There are 94 of us in here. I expect way more answers than one. There we go. We're getting somewhere. We're getting somewhere. It's not just 12. Look carefully. The operations are very important, okay? They tell you direction. Are we going left or right? Are we going up or down? So what is the y coordinate for P? There we go. That will be negative 12. Minus, what is the y coordinate for Q? The y coordinate for Q. There we go. That would be 4. Divided by the x coordinate for P. So we're back to the point P. The x coordinate for P. That would be 5. Minus the x coordinate for Q. Negative 3. Beautiful. I hope we all understand our substitution, okay? This negative, this one over here, comes from the difference part, okay? But then we also have that negative, which comes from the coordinate. So in case anyone is wondering why there are 2 negatives there, first one is from the coordinate, second one is from the difference, the subtraction. So then we're gonna have negative 16 over 5 plus 3, which will give you negative 16 over 8, which is negative 2. Beautiful. I see you guys got negative 2. Brilliant. We're getting somewhere. We are getting somewhere. Remember, Abu, we are polite in the chat. Yes, Chief. Yes, Chief.
Hi, ma'am.
Hello.
Ma'am, I'm confused.
Okay, where did I lose you?
Ma'am, by the negative 12 and the 4, I thought the 4 was a positive, so I'm confused as to why is it changed to negative 4.
What does the formula have, Chief? Look there. What is that?
Oh, it's a negative.
We're subtracting. Do you see why it became negative?
Oh, okay. Okay, now I see.
There we go. So remember the formula has a subtraction, okay?
Okay, thank you, ma'am.
You're welcome. So remember, same with the bottom. The first minus is because we are subtracting, but the second minus is because the point is negative. Okay, it's a negative 3. Okay. Oh, Abu was just excited. Lol. It's okay, Abu. I'm sorry. I don't want to kill your excitement. Okay. Now that it seems like we all get this, I need to go back up and tell you this important piece of information. Remember, we dealt with increasing and decreasing graphs, right? So if you do this whole sum and you do your substitutes and everything, and your answer ends up being positive, so you get a positive gradient, then you will have an increasing graph. Do we all remember what an increasing graph looks like? That would be this one over here. Okay, so it's going up. The values are getting greater and greater and greater. That would happen if you get a positive answer for your gradient. But if you get a negative answer for your gradient, then you have a decreasing function. That would be this guy over here, which is going down and down and down and down and down and down. Okay, so you can tell the shape of your graph according to the gradients that you get. Does that information make sense? I see a hand went up. Kwezi. Yes, Kwezi.
Ma'am, can I please try another example?
Okay, we're gonna do one just now. Don't lower your hand, okay? Okay, Papedi, do you have a question?
Yes, ma'am. I thought like if you wanted to check a positive gradient, you put a smiley face. If it's negative, you put a sad face.
That would be non-linear graphs.
Oh, okay, ma'am. Thank you.
Okay, don't mix up the concepts. Non-linear graphs are the ones that deal with the smiley face and the sad face. Now we're working with linear graphs. Okay. There we go. There's supposed to be arrows on the graph. Yes, Abu, there are supposed to be arrows because the graph keeps going on and on and on and on. Okay. So if your gradient is positive, then your graph is increasing. If the gradient is negative, then your graph is decreasing. We're good. Okay, now let's practice finding more gradients. So far, we have worked out gradients involving points that I've given you. But in reality, you're probably going to find a gradient for a sketch of a graph. So in this case, you would have to find points on the graph to use. Now listen carefully. It does not matter which 2 points you use. You will find the same gradient. Okay, so now let's choose random 2 points on this graph. The first one I see is that one. The next one is that one. I'm going to name this point A. And this one is already point B. Okay, what are the coordinates for A and B? So if you get a graph, you have one extra step, which is to find the coordinates you're going to use. It's easy if they give you coordinates, but you might have to just find coordinates on your graph. So what are the coordinates of A and what are the coordinates of B? Yes, Chief. Andy Dumeleng and Palesa and Komotso, we're doing well. So the coordinates of A are, is it a -1 and 4, and for B, it's the origin, so that would be 0, 0. Now, let's remind ourselves of the formula for gradient. Okay, so M gradient, okay, let me write it on the side, away from these lines. M will be equal to the y of A minus the y of B, all divided by the x of A minus the x of B. What is the y of A? What is the y of A? 4, thank you, minus the y of B is 0, thank you, Abu. Abu has given us a nice formula there. -1 minus 0. This is just going to end up being 4 over -1, which is -4. 4. Does this gradient make sense? Does it make sense? We just said negative gradient means decreasing graph and positive gradient means increasing graph. Yes. So if you made a mistake in your calculation, let's say you got a positive answer, you would know that you made a mistake because you are supposed to get a negative answer. This is a decreasing graph. Can we see that it's going down? So you know that you are supposed to get a negative answer. Okay, so you use these two things to compare with one another. Okay. I see people say makes sense, or it's like, oh, which is beautiful. Let's do more. Let's keep going, guys. Okay, random 2 points. Let's see. Which random 2 points do you see on this graph? Give me 2 random coordinates that you see on this graph, guys, and I will use it. That is beautiful. I like that we get it, guys. I like that we get it. Give me 2 random points that you see. Almost says 1 and 2. Yep, that is a point. Here we go. 8 and 4. Beautiful. Okay. Now I need to name these something. So let me name this B and E. Okay, we have 2 points. Okay, what am I? Oh, you guys already told me the coordinates. Okay, B was 2 and 1, I believe. And E, 8 and, okay, the chat is in my way. Let me move it so I can see. 8 and 4. So your gradient is going to be the y at E minus the y at B. Let me emphasize, guys, if you start with the point of B, it doesn't matter. Okay, you will get the same answer. How about that? How about I challenge you guys to start with B instead of E, or to use 2 different points and see if we get the same answer. Okay, x of E minus the x of B. So I'm going to use these. You guys can use any other point on this graph and let's see if we get the same answer. So with my formula, it's going to say the y of E, which is 4 minus 1 over 8 minus 2 equals 4 minus 1 is 3 over 8 minus 2 is 6. This will give me 1 over 2. Did anyone else get the same answer with 2 different points? Therefore, my gradient is 1 over 2. Anyone else use 2 different points and get the same answer, or are we still busy? Natasha, if you're lost, raise your hand. Let's see. Abu got 1 over 2. Kimora, I don't know where the sign may have gone wonky there. Yes, Papedi. Papedi.
Sorry, ma'am.
There we go. Oh, never mind. You're muted again.
Oh, I'm sorry, ma'am. I forgot to put my hand down, ma'am.
Okay, okay. That's fine. Let's hear Natasha.
Hi, ma'am.
Hello.
I'm not sure if I can really understand. I could understand the way you did it before, but this time I'm not sure where